Hi everyone, this is Mrs. Musoff. Today we're going to be talking about compound interest, which is a specific type of exponential growth that references, the interest that you make on money or the interest that you have to pay on money. All right, so specifically compound interest is what we refer to as interest on interest. And what that means is, suppose you deposit $100 into an account that makes 1% interest. Let's just say for convenience sake. All right, 1% of $100 is $1. All right, so let's say a year passes and you made a 1% interest, right? So that means you made an extra dollar. Well, now you have $101. So when you make your interest for the next year, you're not making another dollar, you're making 1% of $101, which is going to be just a tiny bit more than a dollar. Right, so that's interest on interest. You didn't just make that same 1%, you made a tiny bit more because there was that extra interest added on. All right, when it comes to calculating information with compound interest, like how much money you would make after the fact or how much money you need to start with, we use this formula right here. All right, A equals P times the quantity 1 plus R over N, all to the N times T. Alright, this formula should look relatively familiar because it is very similar to our exponential growth formula, which is this right here. Okay, it is different letters in some cases, but there's still a value on the left side of the equal sign. There's a value in front of the parentheses. There's a 1 plus expression in the parentheses, and then time is up in the exponent. Alright, so it's a very similar formula, and not only are they similar in looks, but in terms of what the letters mean, they're also very similar. The only difference is that this formula has an extra variable, and that's this n variable that just shows up in two different spots. Okay, but the variables that are familiar to you, right, or at least the location they're in, still mean the same thing. So like in this formula, y is the one on its own, a represents that here, but they still mean the same thing. It's the amount that you would make after so many years. So I tend to call it the final or future amount. Right. In this equation, it's just for sure money we're talking about because it's interest, so that's why we can specify that it's an amount. Okay, P is the same definition as A. It's the initial amount. The reason it's called P is technically it's called the principal. Right? With money, the initial or the original amount you invest or deposit is referred to as the principal amount. But in parentheses, I'm just going to write that's the same thing as the initial amount or the original amount. All right. R is the same value. It still represents the rate written as a decimal. So if I had 5%, it would be 0.05. Alright, and then to skip n temporarily, t is still the same thing, and that represents time in years. Okay, so the only new variable that this formula contains is the n value, and n has something to do with how much compounding happens. So n is the number of times that interest compounds in 1 year. Right, number of times interest compounds. And so usually we say the number of times interest compounds annually, but I'll just say in 1 year. Okay, so there will always be a key word in every problem you do that tells you how many times it's going to compound in a single year. For example, if I said it was going to compound monthly, right, you would think, oh, how many times in a year would that be if it happens every month? Well, there are 12 months, so that'd be 12. All right, so that's the kind of thing we're going to think about with n. All right, so let's go ahead and take a look at our first example. Okay, example 1, it says you deposit $2,000 into an account that pays 6% interest compounded monthly. How much is in the account after 10 years? So whenever you see a problem that says interest is compounding, right, that's how you know you're going to use this formula. So I'm going to write it down again just because I don't want to have to keep scrolling. And I want to know exactly what values I need to find and where to plug it in. Alright, so anytime it says interest compounded, that's when we turn to this formula. And the question will always tell you which of these variables we don't know. So it says how much is in the account after 10 years. That's a future value, so that would be a. That means I'm going to solve for a in this equation. So I should be able to plug in numbers for every other variable on here. P is the initial amount, the principal, and it says you deposit $2,000. So that means my initial amount is going to be $2,000. So I'm going to plug that in first. Okay, it's always 1 plus in the parentheses for compound interest. It's like 100% you start with, right? So always start with 1. And then the rate is the next thing I need. Any percentage, right? That's your rate. You just have to write it as a decimal, so that'd be 0.06. Right, and this is where the new part comes in. N is the number of times it compounds in a year. So you're going to look and see where it says that interest compounds monthly. And this is the same example I just referred to before. Monthly, if it's compounding monthly, you think, okay, how many times in a year is that? Well, there are 12 months in a year. So that means it would happen 12 times, so N is going to equal 12. All right, now make sure you remember there are 2 locations for N in this formula, so that 12 is always going to go in 2 spots. All right, the last piece of this is how much time is passing. It says after 10 years, that means T is going to be 10, so that's what I would plug in this last piece. Now, since the part I'm solving for is already on its own, that means I can just type this entire thing into the calculator. The one thing I'll warn you is to make sure, for some calculators, this exponent is going to need to be in parentheses. So I just always put it in parentheses just to make sure you're good. That way, hopefully, there's no confusion about what to do. Okay, so let's take a look. Let's type it in. I'm going to type 2,000, parentheses, 1 plus 0.06 divided by 12. And that fraction doesn't need parentheses, although you could type them in. Just make sure if you do use parentheses, then you're going to have a double parenthesis on the end. Okay, and then for my exponent, I'm using the caret button. And this is where I'm going to do another parentheses just because some calculators do need it. All right, I use that 12 again, and then times the years, which was 10. Okay, and then I'll press enter. This is the amount that I should end up with after 10 years. Remember, if I'm making interest on it, it should be more than I started with. Well, I obviously started with 2,000. I ended up with almost 4,000, so this seems reasonable, right? If I had ended up with like 500, I know I did something wrong. All right, so my final amount is $3,638.79. And I'm going to remember my units. And there's my final answer. All right, so the calculator really does a lot of the work with compound interest. That's why it's so handy to have one. But you do have to make sure you can identify each value to type in. Okay, so let's try one more to make sure. Example 2, you deposit $100 into an account that pays 2.5% interest, compounded quarterly. How much is in the account after 35 years? So again, I see interest compounded, and that's going to tell me that I need to use this new formula we've learned. All right, so I'm going to write it down again just so I can see it. And it says how much is in the account after 35 years. So once again, that's my final value I'm solving for. And that means I should be able to find the values for everything else. So P is my initial amount. That's how much I'm depositing, $100. R is my rate. Remember to turn it into its decimal form, 0.025. And now N, let's talk about N briefly. It says interest is compounded quarterly. So when I think about N, I need to ask myself, quarterly, how many times in a year would that be? Well, think about every quarter. That's representing like a fourth of the year. So quarterly is going to mean 4 times in a year. All right, so that's the value that I would plug in both spots for N. And then the last piece is time. That's 35 years. So this is what I'm going to type into my calculator. All right, so let's try it again to make sure. 100, parentheses, 1 plus 0.025 divided by 4. Use the caret button for your exponent. 4 again. Oops, I'm going to use parentheses just in case. And then times 35 because that's how many years. Okay, and again, the amount you end up with should be more than you started with because we are earning interest on the money. All right, so $239.20. Since the 5's after the 3, I'm going to round up, so 24 cents. So A is $239.24. All right, making sense so far, I hope. Good. Then let's take a look down here, and I've given you kind of a little cheat sheet just to remind you what the different options are. We saw these two in the examples we did in terms of what n could be, right? How many times interest could compound. So monthly is 12, quarterly is 4. Some other examples that you might see in problems: annually, that's just once a year. Semi-annually in math, semi means like half. Right, semicircle is half a circle. Semi-perimeter is half a perimeter. Semi-annually means half. That means once every half year, so it'd be twice total. Weekly, just think about how many weeks there are in a year, 52. And daily, same thing. All right, but there's actually one level further that we take it, and that is if compound interest is happening continuously or constantly. Right? There's no time value if I say I'm constantly compounding interest. So we have a separate formula for that. So for continuously compounded interest, we call this the PERT formula, because on that right side there it spells PERT. All right, so it's A equals P times E. That's that number that we learned about in the last lesson, right? E is Euler's number. And we're going to use our calculator to, type it in. So don't worry about knowing the number. It is approximately 2.718. But again, we'll let the calculator deal with that. And all the other variables in this formula still mean the same thing. A is still my final amount. P is the initial. T is time. And R is rate. All right, so the only difference here is we don't have that parentheses 1 plus piece. E is going to represent that for continuously compounded interest. All right, so let's try an example with that new formula to make sure it makes sense. All right, example 3, you deposit $100 into an account that pays 2.5% interest compounded continuously. How much is in the account after 35 years? So again, when I see interest compounded, that should now make me think of both of the formulas we've learned. So interest compounded could be the original formula, which I'm just going to write down here. Or now we know it could be the PERT formula, P-E to the R-T. All right, R and T are in the exponent, just in case that isn't clear from the way I wrote it. Okay, the way you can tell which of these equations you're going to use is based on how often interest compounds. If interest compounds a set number of times, so monthly, quarterly, annually, right, all those words we talked about, then we would use the top formula. But if interest is compounding continuously, there's no number you can put on that, and so that would tell you to use the PERT formula. Okay, so I'm using that new bottom formula. It says how much is in the account after 35 years. That means I'm looking for my final amount. I deposited 100 in again. And instead of the 1 plus, I'm going to use E, and that's what I'm going to type in my calculator. E, and then now my exponent is R, so 0.025, times T, which is 35. This is the same problem as in example 2, but instead of interest compounding quarterly, we are compounding continuously. So that should mean we end up with a little bit more. Let's find out. Okay, so to type this in, I'm going to type in that 100 again. To get E on our calculator, there are 2 spots, but the one that I showed you in the previous video was right here where it says ln. Right above it in blue is e to the x, so I would do second ln. All right, and then in the exponent, again, I'm going to use parentheses. It's going to be the rate times the time. Okay, and so that would be my total amount, $239.89 because of rounding. All right, $239.89. And again, remember units, just so we know what we're referring to. Okay, if you look back at the previous example, it's only about 65 cents off, right? So it's really not that much more, but if it was more money or interest was higher, right, those are the kinds of things that could make it more significant. So continuously is still going to give you that bigger number. All right, that's all for today. Thanks for tuning in. If you have any questions, just make sure you write them down so that you can be sure to ask them. Have a good one.